This is some problems from a pre-calculus study guide over mostly exponential and logarithmic equations, I believe. So this is from one of my tutoring students, but I think it would be helpful for anyone. I think I've got 7, 8 problems here. So yeah, let's jump in, grab your calculator, pencil, paper, and anytime I'm going too fast, just pause. All right, solve the equation, write the solution set with the exact values given in terms of common or natural log, also given a decimal approximation. Okay. All right, so we have 7, 1 minus 6 to the 1, 7 to the power 1 minus 6x equals 5 to the power 4x minus 3. If we could get a common base, like if this was a 49, and we would just turn that to 7 squared and we'd be in business. But we can't. Not with a 7 and a 5. I don't see a common base possible. So we're going to log both sides. You can either use like log, the common log of base 10, or you can use natural log. It doesn't matter. I'm going to use natural log. I use a cursive L for natural log because otherwise to me that looks like 1n. So that's why I use cursive. We're going to do that on both sides. Or again, you could do log, the common log. Properties of logs, we can popcorn the power to the front. So that's 1 minus 6x natural log 7 equals, let's take this power, popcorn to the front, 4x minus 3 natural log 5. Okay. Now you want to move the algebra to one side and the logs to the other. Doesn't really matter which way you move. I think I'll move my logs to the left because alliteration sounds good. So I'm going to divide this one by natural log 5, cancels off, and I'm going to divide by natural log 5. So we've got 1 minus 6x times natural log 7 over natural log 5 equals 4x minus 3. And now let's move all the algebra to the right. So I'm going to, this is times, right? So I'm going to divide 1 minus 6x, get off, divide 1 minus 6x. So now with natural logs, when you're dividing, or if you just did log, doesn't matter. You know the property of logs that if you divide them, you really subtract. So this is going to be log of 7 minus 5 equals the algebra. 7 minus 5, of course, is 2. So natural log of 2 is blah, blah, blah. Given in terms of a common or natural log. Is that the answer? Like, I feel like that's the exact, I guess we want X though, don't we? How would we get there? Hmm. Sorry, it will hit me in a second. We could certainly go ahead and get the decimal approximation though. Fraction for x minus 3 over 1 minus 6x. I'm going to clear this for a second. You're going to zoom in. We're going to go tight because we need it to 4 places. There we go. So looks like it's closer to 0.4527 would be our 4-place decimal approximation. But if you're not allowed to use Desmos, then you can't put that in the calculator. Okay, we got to solve this for X somehow. How? Sorry, I'm just having a brain issue. Let me reverse and bring back the work. Okay, I think go back to my pink step there. How do we get off a natural log? We raise it to the E. E and natural log cancel out, but then you do E right here too. So this is 2 is E to the 4x minus 3 over 1 minus 6x. Does that help us solve for x though? No. Why did that not work? Like it's correct, but I don't think we can get x by itself. Let's just start this all over. Doo, doo, doo. Except I don't know what I would do different. It's gonna hit me, I promise. Let's see. This, so you would log both sides, drop down, drop down. So 1 minus 6x times natural log 7 equals 4x minus 3 times natural log 5. Okay, maybe we should distribute. So distribute this natural log, distribute here. So that'd be natural log 7 minus 6x natural log 7 equals, distribute here, distribute here. So it'd be 4x natural log 5 minus 3 natural log 5. Okay, here we go. I think this will work. All right. Get everything with the x's to one side and everything that's like non-x to the other. I'm going to add 6x ln 7, add 6x ln 7. So that cancels here. And then I'll move the non-x's the other way. So I'm going to add 3 ln 5 and add 3 ln 5. Okay, so we have ln 7 plus 3 ln 5, natural log, whatever, equals 4x ln 5 plus 6x ln 7. Now don't combine, right? If these were the same natural log, you could, but they're not. So don't combine. All right, but what you can do is that this side has a GCF, greatest common factor, of x. 4 ln 5 plus 6 ln 7. There we go. I've got it now. And now we just want x by itself. So we will divide by the parentheses here. Get off and divide by 4 ln 5 plus 6. That is your exact answer for x that you will type in the exact solution. On the top, ln of 7 plus 3 ln 5 all over 4 ln 5 plus 6 ln 7. There we go. And now let's take that to, you could use Desmos for this or a regular calculator. We're going to make a fraction, natural log 7 plus 3 natural log 5 over 4 natural log 5 plus 6 natural log 7. And it should be, ooh, okay, so it wasn't that same decimal I had before. Interesting. Huh. So round it off to 4 places. 1, 2, 3, 4. This would bump, which would bump 0.374. Huh, okay. 0 if you want the 4th place. That would be your decimal approximation. Let's make sure that's right. And how we do that is just put in the original. So it was 7 to the power 1 minus 6x equaled 5 to the power 4x minus 3. And we should see a line at the answer. Yeah, okay, so zoom in. Is that 0.37, blah, 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 blah. Yep. See, that is correct now. 0.374, which this rounded 37 bump to a 4. There we go. That's correct. Okay, great. Sorry for the problem solving, but we got there. Solve. Okay. We have, let me get some paper. Number 2, or I'm sorry, I don't know what number this is, but it's the second one I'll be doing. E to the 2r minus 12e to the r minus 28 equals 0. Okay, we are going to pretend. We're going to make a substitution. Pretend that e to the r is x. And then if you squared that, e to the r squared, you know a power to a power, you multiply. R times 2 is 2r, and that if you square this side, we'd square x, right? If this is x, square it, this is x squared. Now make a substitution. Well, e to the 2r. Well, look here. E to the 2r, x squared. Minus 12, e to the r. Well, that's what we said was x. Minus 28 equals 0. Factor however you factor. I do magic x. Negative 28 and negative 12. Multiply there, add there. Owe me 14, give me 2. X minus 12, excuse me, x minus 14. X plus 2, set to 0, set to 0. X is 14. X is negative 2, but we weren't solving for x, right? We need r. Well, e to the r is x. So wherever we see x, put back in e to the r. So e to the r is 14. E to the r is negative 2. And then how do we get off e? We take the natural log, get off. So this is r. Take the natural log. Right here is 14, or natural log 14. And then on the other one, natural log, get off. So that's r. Natural log. So natural log of negative 2. But wait, this does not exist. Logs do not input negatives. So that's an extraneous answer. That's not a good one. So it's just your exact solution is natural log 14. Pop that through any calculator, and let's round off to 4 places. Natural log 14. 2.6391 rounded. Much easier than the first one. The pretend is your trick to this one to make it a pretty easy algebraic solve. And again, we could check. So that would be e to the, I'm going to do 2x. Desmos doesn't know r. Minus 12, e to the x, minus 28. And we should see a line at wherever I said natural log 14 was. Yep. And then let's go like this. X equals natural log 14, and it should cover up the blue line. Yes, we're good. Number 3, solve. Okay, let me get paper. E to the 2x equals negative 5 e to the x. Okay, well, I'd love the e's to be on the same side, so I'm going to divide e to the x, get off. Divide e to the x. You know there's a 1 here. When we are dividing powers, we really subtract. So that'll be e to the 2x subtract 1x equals negative 5. 2 minus 1 is just 1x, so this is e to the x equals negative 5. Take the natural log, because that cancels e. Take the natural log. Natural log of negative 5 does not exist. Logs cannot input negative. Nope, no solution. If you graph that one in Desmos, you would see no line coming down because there's no answer. Solve the equation. Okay. Here's a logarithmic equation. You want to combine the logs or condense them first. All right, I see a plus, so that means we're going to multiply. So we're going to have log base 6 of this multiply this. So 5 minus m multiply negative m minus 4 still equals 2. Let's go ahead and multiply that. So that'd be negative 5m, negative 20, positive m squared, positive 4m equals 2, and that's still log base 6. And now combining like terms, negative 5 and 4. So we'd have log base 6 of m squared minus 1m minus 20. And now let's heart this. This is just my cute way to do turning log into exponent. So you put your pencil there, loop around, makes a little heart. 6 to the power of 2 equals blah, blah, blah. 6 squared is 36. Let's get this set to 0, so I'm minusing 36. 0 is m squared minus 1m minus 56. Magic x, or however you factor. We need to multiply to negative 56, add to negative 1. Owe me 8, give me 7. So our babies would be m minus 8, m plus 7, set to 0, set to 0. M is 8, m is negative 7. Now, you do have to check these. It's possible that one or both may not work. Okay, so put in 8 everywhere we see m. 5 minus 8, that is negative. That is not going to work. He's an extraneous, cross him out. Let's try the 7. Excuse me, the negative 7. Try that. Everywhere you see m. That'd be 5 minus negative 7. Well, that would turn to plus. That one's positive. Okay, now we got to try it in this one. That'd be negative 7 minus 4. Well, that would turn to positive 7. 7 minus 4 is positive. You're just checking that these come out positive, and this one does. So just negative 7 is your answer. Okay, to check this one, in Desmos, to get log base something, come to functions, come all the way down? No, not all the way down, sorry. Come under the calculus section, and there it is, log little a, and now we can push 6. And then it was plus, let me do that again, log little a, and then 6. Okay, now what was it? 5 minus m, negative m, m. Oh, we gotta put x. Desmos doesn't know m. And then it was m something, negative m minus 4, I think. Oh, not m, sorry. Gotta put in x. And then that equaled 2. Okay. All right, we should just see one line coming. It is possible to get 2 answers, but remember that one answer didn't work. Yep, and it's at negative 7. And you can check that by going x equals negative 7, and it covered up. Solve the equation. Okay. This one, we can actually change the base. So 9 and 81. Well, you know 81 is 9 squared. Now, once the base is the same, capuche, capuche. X squared minus 23 is 2. Solve. Adding 23. X squared is 25. Root. X is plus or minus 5. 2 answers. 5 and negative 5. You do not have to check this because it's not log. You should be fine. But I will. Like, I mean, you won't get extraneous. Yep, 5 and negative 5. Looks good. Solve. Let's, yeah, I think let's chart. So this would be bump, bump, bump. So that's 2 to the first is log little 2 of x. Well, 2 to the first is 2, and I'm going to put it over here. We're allowed to do that. And now let's hard again. Bump, bump, bump. 2 squared is x, so 4. And you do have to check because that's a log, but that's positive. So just 4, I think. Log 2x. Let's try it. Let me hit that button. Let me hit that button again. There we go. Log base 2 of, here, I could have just copied and pasted, couldn't I? Of log base 2 of x, and we got 4. Oh, did it equal something? Equals 1. There we go. And 4 looks good because it's, yeah, that's 4. Last one, solve the equation. All right, let's distribute this through, I think. So that would be 3. This has a 1, this has a 1. When we're multiplying, we add. 1 plus 1 would make e to the 2x. And then this one would be negative 15, excuse me. Negative 15 e to the x equals 4e to the x minus 6. This one is going to be one of those pretend ones again. But let's get everything over to one side. So let's minus 4e to the x, and let's add 6. So minus 4e to the x, add 6, bye-bye, bye-bye. So that's 3e to the 2x minus 19e to the x plus 6 equals nothing. Okay, now we're going to pretend that e to the x is, let's call it a. You can call it whatever you want. So if you square that, e to the x squared, multiply, that's e to the 2x, and then you'd square a, so a squared. So now this is 3a squared minus 19a plus 6. Factor, 3 times 6 is 18, negative 19. Multiply there, add there, owe me 18, owe me 1. So this would be a minus 18, a minus 1, but we cheated with this 3. Divide it, divide it. I'm going to come in pink. 18 divided 3 is 6, and you just leave the other one. Set to 0, set to 0. A is 6. A is a third. But we weren't solving for A. So come back over to the pretend. Well, we pretended that e to the x is A. So let's put 6 in for A. So e to the x is 6. And let's put a third in for A. E to the x is a third. We just want x. Take the natural log, that cancels. Take the natural log. So x is natural log 6. Take to the natural log. Take the natural log. X is natural log 1/3. So your two exact solutions, and these are both positive numbers, so these both should work. Your exact solutions are natural log 6 and natural log of a third. You might put that in parentheses. Okay, and then you'll push both of those into calculator separately and round off. Natural log 6 is 1.7918, and natural log a third is negative 1.0986. Okay, let's check that. Or e to the x. Okay, and we got x was natural log 6. Let's see if it covers up. Yep. And we got x is natural log a third. Yep, we're good. Alrighty, that's it. I hope this was helpful and I hope you're having a great day. Let me know if you have any questions. Bye-bye.